Okay, so lesson 1 part 2. This one is to do with why is the earth moving, why is it changing, okay? What is it causing it to change? Okay, so in the last part we said that the mantle was molten rock. Well, why is it molten? Why is it so hot under there? Inside the mantle you've got something called radioactive rocks. And it's these radioactive rocks that produce the heat source that heat up this mantle. Now, when you heat up a liquid, remember this is a liquid that behaves like a solid. When you heat up a liquid, what happens is that when you heat it up, it spreads out, which makes it less dense. So it starts to rise to the top. Okay, so it goes upwards. So the hotter the liquid, it rises up to the top because it's less dense, because it spreads out. It's how a hot air balloon. So you fill a hot air balloon with hot air. The hot air then rises up. Okay, in this one, we give the magma a lot of heat energy. It then rises up. Okay, once it gets to the crust, it cools down, and when it cools down, it falls again. Because when it cools, just like with a hot air balloon, when it stops being so hot, it will sink again. Well, it's the same thing with the magma in the earth. Okay, it rises up, it goes to the crust, it cools down, it then sinks back to the bottom again until it gets heated up again, and then it continues. And we call this is called a convection current. Okay, and that is really important for when it comes on to what's happening on the surface of the earth, on the crust. Okay, so if you imagine here, I've got some rising air, some rising magma, sorry, and here I've got some falling magma. Okay, can you see that here and here, there and there, I've got a point on the Earth's surface where these two bits, they're moving away from each other, and hot magma is coming up in the middle. Well, we call that is called a constructive plate boundary. And the reason why it's called that is because you've got all this constructive, means it's building new land, and it's all this fresh magma going up. That's a constructive plate boundary. And now if we move here to this part of the world, and if you look, what I've got here is I've got a convection current next to this one, where they're both going into each other. So if you had a bit of land here on a plate on the mantle, and a bit of land here on the mantle, they're both going into each other. Okay, and we call that a destructive plate boundary. Because what they will do at that point is that when they collide into each other, some of the land will be destroyed, and some of it will go down here. Okay, some of it will go downwards. This bit here, where it's all going down, that has got a name, and that name is called a subduction zone. And it's a bit like abduction, okay? So the land is being subducted. It's been taken into, imagine the word subway. So subway means under, so sub means under, duction means taken. So it's being taken under. Okay, that's subduction zone. And then your final kind of plate boundary is this. Well, let's say that I'm not quite on a point where it's going under, I'm not on a point where it's going into each other, or where it's being spread out. But what I am is, I'm on a point where I've got two plates and they're running past each other. So one might be going that way, and one's going that way. And this is called a conservative plate boundary. And the reason why it's called a conservative plate boundary is because the amount of land is being conserved. It's not, think of like wildlife conservation. Okay, wildlife conservation is when you try and keep the wildlife the same. So here, look, the amount of land isn't changing, they're just running past each other. And that running past each other just causes earthquakes.